In lesson 2.2, we're going to solve equations. Now, equations are different than expressions. Equations have an equal sign in the original problem. So if I look at example 1, this is an equation because it's been given to me and there's my equal sign right there. Expressions don't have an equal sign when they're first given to you. Now, you might set two expressions equal to each other as you're simplifying an expression, but you don't start out with an equal sign when you have an expression. An equation is made up of two expressions set equal to each other. So this 4 minus 6n is an expression. The negative 38 is an expression. When I set them equal to each other, or when they're given to me with an equal sign between them, that's what makes it an equation. So if I'm simplifying expressions, then I want to work through the order of operations from parentheses, then exponents, multiply, divide, then add, subtract. But if I'm solving, I want to undo by going in the reverse order. I'm going to start at the bottom and go to the top. So first I'm undoing addition and subtraction, then I'm going to undo multiplication and division. So in this first basic example, remember what we did before. We drew a vertical line to represent our equal sign, and then we want to undo everything that's done to the n. This n is being multiplied by negative 6, and the 4 is being added. Sometimes it's hard to recognize that that 4 is a plus 4, that it's being added. So if it helps, put that little plus sign in front of it. So I need to undo the plus 4 first, and I undo it by working on both sides of the equation. I subtract 4 from both sides of the equation. This is going to zero out, and then I bring down my negative 6n equals negative 42. Don't lose your equal sign. It's important to keep up with that. Now I have negative 6 multiplied by n. To get rid of that, I'm going to divide by negative 6. Now when you divide by, don't use the little symbol for divide by. Use a fraction bar because it means the same thing and it will make your work neater and easier to follow. So negative 6 divided by negative 6 is just 1. So I have 1n is equal to negative 42 divided by negative 6 is a positive 7. So this is my answer. If I substitute 7 for the n in the original problem, then it will give me a true statement. Sometimes we write our answer as a set. So the only number in my set is 7 because that's the only number that works. Remember that when you simplify, you're working on one side of an equation, so you're working on an expression when you simplify. When you solve, you're working on an equation, so you're doing the same thing to both sides of the equation. If I look at example 2, I have a lot of stuff on the left side of the equation. There's my equal sign. And so I want to simplify this expression that's on the left side as much as possible. That's not solving, that's just simplifying an expression. I notice that I have a 5a and a minus 3a, and I can combine those like terms to be 2a. I also notice that I have a minus 8 and a plus 1. If I combine those like terms, I get minus 7. And then that's equal to negative 19, which is already a simplified expression. Now I'm ready to solve this equation, so I'm going to extend my vertical line, and I'm going to undo this minus 7 first. Remember, I'm going in the opposite order of operations. I'm going to do the opposite sign there. So if I have a minus 7, I want to add 7, and that's going to zero out. I bring down my 2a, and negative 19 plus 7 is negative 12. Now I have 2 multiplied by a, so I'm going to divide by 2 on both sides, and those 2's are going to 1 out. 2 divided by 2 is 1a, which is what I want. And then negative 12 divided by 2 is negative 6. So this is my solution. I simplified the expression first, then I solved the equation. Pause the video and simplify the expression on the left side of this equation first, and then go through the solving process. I'll give you a hint. You're going to have to distribute the -8 through the group. You're going to have to distribute the 4 through the group. That's your first step. So pause the video and work through that. All right, let's check your answers. There was quite a bit of simplifying to do, so you can see on my example that I didn't start solving until you see something in red. So first I distributed the -8 through the group, and then I distributed the 4 through the group. Make sure to check your signs, and if you need to use a calculator, that's fine. I combined my like terms and got -56 minus 48x. All of that work was done only on the left side of the equation. So I wasn't doing anything to the 40 that was on the other side. But then I'm ready to solve it. So to solve, those steps are in red. I added 56 to both sides, then I divided both sides by -48. Look at example 4. Here's my equal sign, so I know I have an equation and I'm going to be solving eventually. But if I look at the expression on the left side of the equation, there's some simplifying I can do to that. And I can also do some simplifying on the right side, but I'm going to do each side separately. The like terms on the left side are 4p minus 2p, which leaves me 2p, and then a plus 5 and a minus 5, which is actually 0, so that leaves me 2p on the left. And then on the right side, I can combine the 3 and the 6 and get 9. And then there's nothing to combine with the minus 8p, so I just leave that the way it is. And now I'm ready to solve. So this time I have variables on both sides, and I want the variable all on one side. When I'm changing sides of the equation, moving something from one side to the other side, then that's the solving process. So I'm going to add 8p to both sides, which is going to give me 10p when I add those together. Those are like terms on the left side. This zeroes out, and I'm just left with 9 on the other side. So I have 10 times p is equal to 9. I'm going to divide by 10 on both sides. So p is equal to 9 divided by 10. You can write that as a decimal, but you might as well just leave it as a fraction. Look at example 5. There's nothing we can do to simplify the left side, so we're going to keep it the way it is. But on the right side, we need to distribute the 3 through the group. So 3 times 5x is 15x, and 3 times 1 is plus 3. So I've simplified as much as I can on both sides, and now I'm ready to solve. And a lot of times the question is, well, do I move my x's or do I move my numbers? And it really doesn't matter. It's up to you. So what I'm going to do here is I'm going to subtract 4x from both sides. This is going to zero out my x's on the left side and leave a 25. And on the other side, 11x plus 3. Now I'm going to subtract the 3 from both sides because I want numbers on one side, variables on the other side. 25 minus 3 is 22 is equal to 11x because those 3's zero out. 11 is multiplied by x, so I'm going to divide both sides by 11, and I get 2 is equal to x. In example 6, we're going to explore the question, does it matter which step we do first, a little bit further. So pick one of the starting points that's given. You only have to work through one of them with this problem. And then after you pause the video and come back, we'll compare the answers for all 3 starting points. Now that you're back, take a minute to look through the solution for the starting point that you chose. And then look at the solutions for the other starting points. You notice that regardless of the starting points, when the work was done correctly, we got the same answer, x equals 4. So we do have to follow that order of operations by undoing addition and subtraction first, but it doesn't matter what addition and subtraction you choose to perform first. Now pause the video and solve each equation in example 7, and let's compare the solution sets. Now I'm going to warn you that there's some funny things that happen, so just be careful in your solving, and then we'll come back and look at the results. So pause the video. Remember, you may have decided to add 3 to both sides in your first step instead of adding 3x to both sides. So it doesn't matter what your first step is there as long as it's addition or subtraction. And you should eventually get x equals 0, and that's our solution. Now a lot of times people say, well, x can't be 0, but 0 is just an ordinary number. It's a real number. So if you get x equals 0, then that is a solution. But look at our second example. When we subtract 6x from both sides, we're left with no variables, no x's anymore, and just numbers. But we do get a true statement, -3 is equal to -3. So what that tells us is that any x will work. Any value of x will work. So x could be 5, it could be -1,000, it's going to work. So one way we write that solution is to say all real numbers. When the variables go out and we have a true statement, we say all real numbers is the solution. Now when we look at our next example, the variables went out again. We don't have x's in our answer anymore, and we get something like -3 is equal to 3. Well, that's a false statement. And if we get a false statement, then that means that there are no numbers that will work, which means there's no solution. The way we write no solution is just to put an empty set with those squiggly brackets. So take a minute to write down those ideas. How do you know when a solution is the empty set or has no solution? And how do you know that the solution set is all real numbers? Write a sentence for both of those. Here are the sentences that I wrote. You may have used different words, but it should say the same thing. Now pause the video again and find the solution sets for each of the following equations. Alright, so I combine like terms. The 4v and the 2v give me 6v, and -3 and -7 give me -10. And then when I wrote the other side, I realized, hey, those are the same thing. So I don't even have to go through the process of subtracting 6v from both sides to know that this is going to be all real numbers. That's a true statement because this side looks exactly like the other side of the equation. So it's okay to take that shortcut when you recognize it. Now the last example had a fraction in it. Remember that a fraction is just a little division problem. Before we can undo the division problem, we're going to have to undo our subtraction right here. There's a 4 that's subtracted from our variable. So we're going to add 4 to both sides to get rid of that -4. And then after we do that, we're going to multiply both sides by 2 to get rid of the divided by 2, the bottom part of the fraction of x plus 3 over 2. Then we're going to subtract 3 from both sides. That leaves x by itself, and 36 minus 3 is 33.